Hey guys, we're going to start graphing parabolas, or we're going to graph quadratic equations or quadratic functions. You'll also see me graph quadratic inequalities, which are really easy to transition into. Now, we're going to make this a 3-day process. So today we're going to learn to use the vertex and the A value to get some real quick sketches. Now, before we go into using the shortcut methods like the A value and the vertex, we need to just make sure that you understand you can always create a T-chart. Now, I've picked some easy ones to get started with because I want to begin to show you how to think through the A value. All right, so on this first problem, for y equals x squared, I have gone ahead and set up a T-chart for you. So if I say what is y equals -3 squared, remember that means -3 times -3 is positive 9. What is y equals -2 squared? Well, that's -2 times -2, which is positive 4. Uh-oh. You all know how the board does sometimes. Y equals -1 squared is -1 times -1 is positive 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. So when I go to plot those points, I'm going to have 0, 0 right in the middle. That's going to be my vertex. Let me see if I can get it to plot the points where I want it to plot them. Yay! I have -1, 1 and positive 1, 1. I have -2, 4 and positive 2, 4. I have -3, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. This was a computer glitch, sorry. And positive 3, 9. So that would be right here. So my parabola is supposed to be kind of a U shape. So I'm going to do the best I can to make it a nice U shape. Now, some things I want to emphasize. Notice that from the vertex, I went out 1, up 1, out 1, up 1 in both directions. From the vertex, I went out 2, up 1, 2, 3, 4, and out 2, up 1, 2, 3, 4. From the vertex, I went out 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9. So I can use those basic values. Here, my A value is 1. Because it's 1 in front of the x squared. So that means you go out 1, up 1, out 2, up 4, because 2 squared is 4, out 3, up 9, because 3 squared is 9, out 4, up 16, because 4 squared is 16, out 5, up 25, because 5 squared is 25. So I don't expect you to totally get what I said, but I'm going to keep repeating that throughout. All right. So on the second problem, I don't want you to go, oh my gosh, what is going on? There's an f of x there. All right. F of x is the same thing as y. I've got it written in function notation, which we'll talk about more later. But for right now, it's no different than y equals -2x squared, okay? So don't be intimidated if you see that. All right, so on this one, I'm going to say -2 times -3 squared. Well, remember, -3 squared is -3 times -3, which is 9. 9 times -2 is -18. Then -2 times -2 squared. -2 squared is -2 times -2 is 4. Times -2 is -8. -2 times -1 squared. -1 squared is -1 times -1. That's 1. 1 times -2 is -2. -2 times 0 squared is just going to be 0, because 0 times 0 times -2 is 0. -2 times 1 squared, 1 squared is 1, is -2. Negative 2 times 2 squared. 2 squared is 4. 4 times negative 2 is negative 8. Negative 2 times 3 squared. 3 squared is 9. Times negative 2 is negative 18. So remember, when you're using order of operations, you square first, and then you multiply by the negative 2 last. Okay? Now, on this one, my A value is negative 2, and I'm going to see that my counts are different when I plot my points. So I'm still going to start out with my vertex at 0, 0, when we'll talk more about how I know that's the vertex. For right now, I position the vertex in the middle of the t-chart on purpose. So I'm going to plot negative 1, negative 2, and positive 1, negative 2. Oh, look, on that one, I went from the vertex out 1, down 2, out 1, down 2, okay? So I'm also going to plot negative 2, comma negative 8, and positive 2, comma negative 8. So 2, 1, 2, 3, 4, 5, 6, 7, 8. And negative 2, 1, 2, 3, 4, 5, 6, 7, 8. So the last points that I would normally plot, 3 and negative 3, comma negative 18, those are so big that they're off my graph. So really, if I have about 5 points, and we'll get down to if you just have 3 points, you've got enough. You've got enough to draw the parabola. But notice, when the A value was 1, I would count out 1, up 1, out 2, up 4. Now that the A value is negative 2, I'm counting out 1, down, all right, 2. So look, out 1, down 1, 2. I also counted out 2, down, all right, so look, out 2, down 1, 2, 3, 4, 5, 6, 7, 8. So guys, a couple of things. Number one, why are these down instead of out? The down comes from the negative, okay? So if your A value is negative, then you're going to count out and down, not out and up. So if the A value is negative, the parabola opens upside down, okay? If the A value is positive, the parabola opens right side up. Now my next question is, why is it down 2 instead of down 1? Because I'm doubling, okay? Since it's 2, I double my normal up and down counts. So if I would normally count out 1, up or down 1, now I'm counting out 1, up or down 2, because 2 times 1 is 2. All right, again, normally I would count out 1, up or down 4, but I'm going to say 2 times 4 is 8. I'm doubling. So we're going to come back and we're going to make sense of all that for you, but I want you to start thinking about how the A value might double your normal count, triple your normal count, or it might take half of your normal count or a third of your normal count. We won't do ones that are much more complicated than that for right now. All right, last but not least on t-charting. So on this one, I'm going to go ahead and say, let me start with the vertex in the center. 1/3 times 0 squared is just 0, because it would be a 1/3 times 1, or times 0 times 0. If I plug in for 1, it would be 1/3 times 1 squared. So 1/3 times 1 is 1/3. 1/3 times 2 squared would be 1/3 times 2, which would be 1/3 times 4. 1/3 times 4 is 4/3. Ooh, I'm not loving those points. If I did 1/3 times 3 squared, 3 squared is 3 times 3 or 9. A third of 9 is 3. Now, I like that point. So right now, I've got 0, 0, and 3, 1, 2, 3. I like those 2 points, okay? I've also got 1 comma 1/3, which I'm going to estimate to be about right there, and 2 comma 4/3. 4/3 is 1 1/3. So 2 comma 1 1/3 would be about right there. So the right-hand half of my parabola looks like this. Have you noticed yet that we've got symmetry in the parabola? So for instance, on this green parabola, this dot was 1 unit away from this center line of symmetry. So I have another dot that was 1 unit away from the center line of symmetry. Look at this dot. It's 1, 2 away from the center line. So I know I'm going to go 1, 2 away from the center line on the other end. All right. Same thing with the blue parabola. I have a center line or a line of symmetry. These dots are both 1 unit away from this line of symmetry. No. That was the computer doing weird stuff. Sorry about that. All right. This dot and this dot are both 2 tick marks away from the line of symmetry. This dot and this dot are both 3, 1, 2, 3, and 1, 2, 3 dots away from the line of symmetry. So, wait a minute. Is there a way that I could use symmetry instead of having to keep doing t-charting? Yeah, there is, guys. My line of symmetry is always going to go through my vertex. And on these problems, I put the vertex in the center on purpose. So, this dot, here, I'll change to red so you can see it better. This dot is 1 tick mark from the center. So I want one that's about equally low to high and also 1 tick mark away. This dot is 2 tick marks away from the line of symmetry. So if I kind of use that leveling and go 2 tick marks, nope, 2 tick marks on the other side. So these are equally high to low. The second dots are equally high to low. Now my third dots, I've got one right here that's 1, 2, 3. And then I'm going to go 1, 2, 3 on the other side. And that way you can begin to use symmetry to get the other half of your parabola. So if we use all this stuff about the A value and symmetry, we can begin to graph our parabolas much more quickly. All right, on this purple one that I did it half purple anyway, my A value here is positive 1/3. And you might say, why'd you write the positive? Because I wanted to emphasize the positive is what caused my parabola to open right side up. The 1/3 is what caused my parabola to be short and fat, not as tall and skinny as my other ones. So blue, when A is 1, right here, the parabola is normal. It's a normal U shape. It's not tall and skinny. It's not short and fat. It's normal. All right. When my A value was 2 or -2, then my parabola was tall. And if you make it taller, it looks like it's become skinnier too. It's really just stretching it tall. But with the parabola, if you jerk the arms upward and make it taller, or jerk the arms of the parabola downward and make it tall upside down, it's going to look skinnier. And then on the purple one, this one appears to be, let me keep my color coding intact. This one appears to be short and fat. So if you push the arms of the parabola down shorter, it makes it look fatter. Now, let me show you something else. Like on this one, the purple one, my best counts were from the vertex out 1, 2, 3, up 1, 2, 3. So from the vertex, counting out 3, up 3, gave me my cleanest points. I don't like graphing fractional points, and my math lab won't let you graph the points that have fractions. So you want to look for points that have nice, neat whole number coordinates. So where did the out 3, up 3 come from? All right, I want you to look in the first T-chart. 3, 9 said from the vertex go out 3, up 9. All right. So how did I get from out 3, up 9 to out 3, up a third? Because what I did was on this parabola, I said I want to go out 3, up 1/3 of 9, because 9's considered normal, and since my A value is 1/3 over here, I'm going to count up a third of normal. Well, up a third of normal, up a third of 9 would be up 3. So that's the kind of fractional work we're going to be doing. That's going to be the hardest thing that you have to overcome. The rest of this, y'all are going to fly on. So I'm going to break this into 2 short videos, and I'm about to finish my first video, okay? So I know from the other day that we have 3 forms of quadratic equations. So I have y equals ax squared plus bx plus c. This is standard form. I have y equals a times x minus h squared plus k. This is vertex form. I have y equals a times x plus or minus a number times x plus or minus a number. This would be my factored form. All right? So it does not matter what form you're in. Notice you have an A in standard form. You have an A in vertex form. You have an A in factored form. That A value is the same A regardless of form. So notice if A is positive, the parabolas open up. So I've got 4 examples on the first row of the parabolas opening up. And if A is negative, the parabolas open down. So notice on row 2, all my parabolas open down. Now, same thing. I'm still looking at standard form, vertex form, factored form. Okay? Again, A is A is A. It doesn't matter what form you're looking at. A doesn't only tell you whether the parabola opens right side up or upside down. A tells you if you've got a normal U shape, a tall and skinny U shape, or a short and fat U shape. So if A is equal to 1, that's considered normal. Normal means count out 1, up 1 from the vertex, because 1 squared is 1. Count out 2, up 4 from the vertex, because 2 squared is 4. Count out 3, up 9, because 3 squared is 9. All right, that's normal. If I look at A as greater than 1, like if A is 2 or 3 or 4 or 5, or if A is negative 2, negative 3, negative 4, negative 5, same thing, those would just be upside down. This is telling you that you're going to get a tall, skinny U shape, and we're going to work on those A value counts. If A is less than 1, so if A is like 1/2 or 1/3 or 1/4, or if A is negative 1/2, negative 1/3, negative 1/4, those would just be upside down. But you're going to wind up counting in such a way that your parabola is short and fat. All right. Getting into the rest of the lesson, we are going to be practicing finding the vertex, naming the A values, and getting quick sketches of our parabolas. We'll also talk about the axis of symmetry. But guys, if you can find the vertex, the axis of symmetry is a piece of cake. So notice, back on this slide, I had right here, I had standard form and vertex form starred. I would like to do factored form with you, but since we're sort of abbreviating things, since we're having to do distance learning, I might show you a couple of examples with factored form, but that's not going to be our focus. We're going to stay focused on vertex form and standard form. So you just lost part of your daily information. Yay. All right, so on vertex form, the vertex is super, super, super duper easy to see. You just look. This will give you the x coordinate of the vertex, and this gives you the y coordinate of the vertex. Super, super easy. So it's x minus the x coordinate of the vertex. So consider, well, I'll show you in a minute, all right? And then the y coordinate of the vertex is what I call the caboose of the equation. And guys, the axis of symmetry is just the x coordinate of the vertex. You just put an x equals in front of it, and then you wind up getting a vertical line. That's the equation of a vertical line. Now, if you have standard form, you can't just look at the equation and see the vertex. It's more complicated. That's why we love vertex form, because vertex form makes vertex easy. Standard form makes vertex more work. But to find the vertex, you simply use the formula x equals negative b all over 2a. So we cut off the rest of the quadratic formula. But we are going to work out our x using this formula. And then anytime you have an x and you need the y coordinate that goes with it, you just plug in. So you'll see us doing that work. And then if I say, well, what's the axis of symmetry? It's just the x coordinate again. You say x equals that x coordinate, and that gives you a vertical line. So that's where we're headed, and let's take a break and start the next video.